Welcome to Whip Your Scripts into Shape. I'm Josh King. You can find me at king.geek.nz and I'm on Twitter at windowsnz. If you're anything like me and you just go by Twitter avatars, that's me. Or rather, it's not me, but that's who you'll find if you Google Joshua King. Assuming you don't find the sports person first. So, I'll address my accent up front. I'm from New Zealand. Roughly there. So I come from a town called Hastings. I work for the local city council there. And to answer the follow-up questions that I generally get after that is, it took 3 flights to get here, it was about 16 hours in the air. Back home, it's 7 a.m. tomorrow. So let's go on. So the topic of today is speed and PowerShell. They're two things you generally don't hear in the same sentence, unless it's followed with some sort of complaint or curse or, generally negative sentiments. Frankly, my first experience with PowerShell was really slow startup times. They have been getting better, but if that's your first experience with PowerShell, it's going to taint your perception of it going forward. And unfortunately, it is a really, really common complaint. So how are we going to look at speed today? We're going to be doing some A/B testing. And for the purists, I am bastardizing that term a little bit. But in general, we'll have a control and a variance or a variant and running them and seeing how they compare. So I guess in general, if you're looking for improvements, you've got to measure it. There's no point trying to make changes for anything, whether it's speed or disk space, without having something there to prove that what you're doing is right. And make one change at a time. And I guess this applies to all of IT, because if you've got a network issue, you don't go and change your network card, your patch leads, your fly leads, your switch all at the same time, because one of those things probably fixed it, but you're never going to know what. And test more than once. A lot of this is going to come down to random variables. You might have something just recently crashed and free up a lot of memory, or your system might be doing something really intensive at the time and you just ran into bad timing that affected your results. The reality is that by taking measurements, you are going to be impacting performance a bit, so you need to try and minimize that impact. So my tests are going to be run through a run bucket module, and the next couple of slides are going to call out a couple of different modules, so I apologize for it sounding a bit like an advertisement. But like I said, we're going to have a control, which is a script block, a variation, which is a script block, and it's going to do its thing. So a little bit more about that. As I said, I'm going to be calling out some modules. It's using Posh RSJob behind the scenes, and it's running each of those controls and variants 100 times each, unless the example up there shows something else, which is generally done because those test cases took way too long for us to sit here for 100 iterations. Just in case of any massive outliers, I'm ignoring the slowest and the fastest run of each test in both the control and the variant. And I'm using the stopwatch class rather than measure command. And this really only comes up in the first example, spoiler alert, but measure command tends to ignore console output. So if that's part of what you're testing, it might not be the best fit for measuring things. And again, another module, I'm using PowerShell Universal Dashboard to display the results. I did this presentation at work, and this slide is here because of some feedback I got from that. So you're going to be seeing some notifications pop up during this. And they look a little something like this. It isn't Slack. I haven't, left Twitter open. They're part of it. They basically tell me that all my test cases are finished, so that means the results are ready to have a look at. And another module, they're created via burnt toast. So, got 11 demos today that are covering 10 concepts. They will be quick, so we'll be, not here for hours. And these demos may have unexpected results, and that's sort of the point. Just to throw a spanner in the works there, one of these tests are meant to fail, and if it doesn't, then you're going to be wondering which one of those statements was a lie. I'm using numerous VS Code and PowerShell tools, and if you're interested in how any of those mechanics and how that's all wired up, let's have a chat at lunch. The only other thing to keep in mind is you won't see me actually running any code. That's all happening behind the scenes as I pull up each demo, and that's mainly in interest of me not forgetting to start them and us having to sit here in awkward silence for a while. Just to go through what the dashboard's going to look like. Controls on the left, variation in the middle, results on the right. The speeds in the middle there are all milliseconds, accurate down to 3 decimal places. And in general, everywhere, green is good, red is bad. What I'm using to determine the winner is the average, because like I said, we've got all sorts of random occurrences that could get in the way. So the maximum might be high, but the average overall is still low. And a minus there in the percentage means it was, say, 80% quicker. So let's pull up our first demo, and I mentioned console output. So let's talk about chatter. Have you ever noticed that running getChildItem when it displays everything to the screen is a lot slower than if you, see? Is a lot slower than if you're putting that into a variable. And that's because console outputs slows things down a little bit. I don't know if that's intentional or not, but I tend to use it for looking for patterns, and if I see something not in the pattern that I expect, I know to stop it and dive in and find out what's wrong. So the difference here between our control and our variation is, one, we're just dumping it out to the console, and in the variation, we're assigning it to the items variable. This is probably the only demo where the output of the two things are different. Everywhere else I've tried to end up with the same output. And as you can see, we've shaved off, what's that, 13 milliseconds by not on average, by not having the console output. And also the maximum on this is consistently a lot lower. So even if your averages are pretty close there, your maximum runtime you're going to be waiting for is pretty low. And of course this scales, this was testing my drivers folder. That was a whole file server. That's going to be a much different story. Right, so the first thing we all learn when we're learning PowerShell is filter left, format right. And I think we've all just taken that as a universal truth. But let's go ahead and measure it and see what happens. So in our control, we're getting a bunch of events out of the event log. Specifically, we're looking at the application log, we've chosen a specific ID, and we just want everything that was created in the last hour. So in that example, we are piping getWin event to where object, but getWin event lets you filter directly on the commandlet. This, assuming nothing's failed, is probably going to be the one that has the most significant improvement today, I hope. So just by changing that from one pipeline going to where object, we've dropped from 2.5 seconds to 15 milliseconds. And conceptually that makes sense, because what our control's doing is it's grabbing everything in the application log, chucking it through the pipeline, and then figuring out which bits it needs. Whereas when we're using a filter hash table, it's not dealing with that extra data that it doesn't need, or that we don't need. All right, stop poking me. So we get into this a little bit later on, but commandlets and functions in and of themselves have a little bit of overhead. So if you're getting multiple sets of data, if the example that I couldn't pull off here was get AD user, if you're pulling users from multiple OUs or under multiple situations, it's probably better to, rather than making the same call twice, making one call and then splitting them out later. So like I said, I would have preferred to do this with AD, but I couldn't get it working on my laptop. So we're back to win event. So we've learnt filter hash tables really good, getting a bunch of stuff from our app event log, application event log, and a bunch of stuff from our system event log. Rather than doing that, we can do one call to get one event, and then split the events up. So we end up with the same variables at the end, app events and sys events. And fingers crossed, we shave off 5 milliseconds. Like I say, this difference is relatively tiny, but when you start applying this to AD, or much larger data sets, or much more calls. So say if you were doing 4 different event logs, it scales quite well. Now, well, in this case, I picked ones that I know aren't common between them. So yes, good call. Yeah, you would need, so yes. So in my AD environment, our staff are in one OU, our contractors are in another, I could get them at the same time and then split them based on distinguished name. All right, so one thing that's fairly popular with PowerShell is the one-liner contests and trying to make your lines as short as possible. But using things like aliases and shorthand does have a performance impact. So here you'll see I'm calling service rather than get service, the question mark alias rather than where, and I've shortened first to -f. Rather than doing that, when we expand everything out, we see it's about, not quite there, but almost twice as fast. Now, to be fair, this one is probably mostly impacted by just using service there. So if you didn't know, you can drop get off the start of any get-noun commandlet, and PowerShell should be able to figure it out and run the appropriate command. But what it's doing is, when you type in service, it's looking for a commandlet and it doesn't find anything. And I am simplifying this, so I apologize. It tries to find a commandlet, doesn't find it, tries to find a function, doesn't find that, drops down to your system path, tries to find an executable, doesn't find that, and then it goes back to the start and adds get. So it's doing a lot of work there in order to get to that point. Right, the pipeline. And, geez, that completed quickly. So this one, I'm scrutinizing my temp directory, which I've filled up with random stuff. And basically, I just want to get out anything that's longer than 500 bytes, 5,000 bytes. And that's being done by piping to where object. The alternative as of, I think it was PowerShell version 4, is the where method. So your syntax is basically the same. You'll see the filter script is identical between them. but it takes about 2/3 of the time to run that. And again, like all of these examples where I'm showing the file system stuff, I'm running on an SSD here and on a really small directory. When I do this sort of stuff on a file server, it shaves off a lot of time. All right. Now, going loopy. So loops are a foundational part of any sort of scripting, and you'll often see this construct here. Again, I'm picking on that poor temp directory on my hard drive. We're piping the contents to for each, and this time loading up a total length. And of course, the alternative to doing that is putting getChildItems into a variable and then running for each over them. I'm sure it's not news for most people in here, but those two for eaches aren't equal. The one up the top next to the pipeline is an alias for each object, which is a commandlet that's abstracting things and doing extra processing and has all sorts of overhead, whereas function is a statement in the language. And again, it's 2/3 the speed. Well, yeah, it takes 2/3 the time to run as compared to the piping it. So what I'm about to show probably isn't the best demonstration of this, but there's a very real possibility that in a lot of our scripts we're doing things we don't really have to be doing. So we're doing all sorts of unnecessary operations. The reason why I picked this demo is because I recently found out about the version object, or type. So this control example is going to be how I was going to start trying to compare version numbers at one stage. So I'm comparing my PowerShell version, which comes out as an object that looks something like that comment, and I'm going to compare it against the string. And I know from looking at that I need to compare the 5 at the front of that string to the major number, the 1 to the minor number, and so on. And there's a period between each of those numbers, so I can split it and then start going down with a series of if statements and just doing comparisons, seeing if it's greater than or equal to, and returning true or false, depending on where it trips. Of course, as you might have guessed from the title, that's not necessary. Just cast that string as a version, and you can just make the comparison directly. And like I say, this isn't a good example, but it does work in that we've shaved off 0.4 milliseconds, but at that scale, it's a third. But again, I really wanted to put this one in because of that casting. It really helped. All right. So here's where all the public speaking training comes in. So I mentioned before, there's a bunch of abstraction happening in PowerShell to make your life easier. At the end of the day, it's running on .NET. And that abstraction comes with natural overhead. So in this example, I'm generating 1,000 GUIDs, and I'm just dumping them out. Rather than doing that, we can generate new GUIDs via this. The output is exactly the same. And if we generate 1,000 of them, yeah. So other examples I've seen where this applies is things like pinging servers. There's I think it's the net connection class you can do it through. I always have to look it up when I do it. But if you're able to write it doing anything in the .NET syntax is going to be faster. I mean, frankly, if you wanted the absolute best speed, you'd be writing machine code, but nobody's got time for that. Right. So, we've been using collections a lot, so it's time to become a collector. The most common thing I see in scripts is this notation here, where we're defining an empty array and then using the plus equals operator to assign new values to that array or to that collection. But even though that you're using that plus equals PowerShell, well, that collection doesn't actually have a method of adding new items to itself. You're going to PowerShell, here's a collection, here's a new item, I need these two things mushed together, and it goes, all right, I'll create a new thing with that attached. And then it just repeats, destroying and recreating the object over and over again. Instead of doing that, and the default way I've started doing this now is using an array list, which does have an add method, so you can add items to the collection. So this example here in both cases, generating 1,000 random numbers, adding it to the collection. The only thing I will say about array lists is using that .add method will output things to the console. So hence why I'm doing null equals there to silence that. Yeah. Yes?
Is there a speed variation if you do null equals versus out null?
Yes, and I didn't put that in as a demo, but yes. I think if you do redirection like that, it's closer. But for me, I just always go for that one. But yes, definitely going out null is a lot slower.
For this, there's commandlet overhead and pipeline overhead.
Yes.
When you pipe out null.
Yep.
You can also do a topcast void on it.
Yes. So yeah, that's another one where the increase is significant. Well, sorry, the speed up is significant. All right, so after you've become a collector, the next step is becoming a hoarder. So our control here is our variant from the last example. And our variation is just assigning the output of that for each loop directly into a variable. This one is faster, but personally I still go with the array list just because I like the syntax. But if your goal is speed, doing that works. And I guess the mother of all speed ups is parallelization. It's always a tongue twister. So, as you might have guessed, I'm using PowerShell job for this one. But the example code I've got here is I've got 4 targets out on the internet, the 2 Google DNS servers, Quad 9s, and a random news site from New Zealand. Looping through each of those, pinging it twice just to slow things down a little bit, and then returning an object just saying what the host was and whether or not it responded. And the alternative there is using PoshRS job to do those test connections in parallel. So again, probably not so much for this room, but for the benefit of people at home, everything so far has been basically a sequential operation. So think of it like the supermarket. All the tasks you're doing are people waiting to get through the checkout. and the supermarket's got one checkout open. Checkout operator can only process a customer in about a minute. So if there's 30 customers, it's going to take that operator 30 minutes. If they opened 10 checkouts, they can process 10 customers at once. Each customer still takes a minute to get through the checkout, but now it's taking 3 minutes to process all 30 customers. And that's what using a parallel job like this is going to do. And as you might expect, the maths didn't add up. Hang on, let me rerun that and hope it works. That's probably the worst one to have run because it takes about 10 seconds. Like I said, the awkward silence of waiting for it to finish. All right, I know what it is. I'm not on the internet. So I'll talk through this one. Generally, what you'd see here with 4 hosts and 2 echo requests is that it'll take about 8 seconds to complete the control. And the maths works out that it should take about 2 seconds to complete the variation because it's doing all 4 of them at once rather than 4 of them in sequence. Didn't think about signing into the Wi-Fi. In fact, airplane mode. All right. So I guess the question after seeing all of those is, are they a silver bullet? And the simple answer is, well, yeah, no. So depending on the data you're working with or the systems you've got or the workstation you're working on, you might, and did I say data sets? You might run into memory consumption issues, you might run into CPU bottlenecks, so you need to sort of profile what you're doing. Also, by trying to optimize it, you might break a working script, and we'll touch more on that in a second. And your environment's a snowflake. Just being here, looking around the conference in general, I see a lot of Lenovo laptops, I see a lot of Dell laptops. In New Zealand, we have a lot of HP. Our server environment at work is HP. I'm going to go out on a limb and say here, maybe not as much, at least maybe. But what I'm getting at there is, I don't know what's going to work well in your environment. That's your baby. So the takeaways from this is don't assume or don't be a stick in the mud. If you've learnt to do something one way, don't think that that's the only way to do something. If you hear of or see or think of a new way of doing something, give it a go. Test it, see how it works, see if you like the syntax. You might find you like that better than the way you've been doing things. Measure twice. Like I said at the start, and as happened here with the Wi-Fi, random variables will come into play. And running a test once isn't going to be a true reflection of truth. So every time I've run these demos, I've had different results. I've had different things not be faster, depending on which way the wind's blowing. And revisit. Microsoft's really good at pushing out updates. And chances are those updates are going to occasionally potentially make something slower, make something faster. So there's no harm in, especially if you've saved all your test cases, trying them again in 6 months, 12 months, 2 years. Just keep an eye on it. And worry about optimization after it's working. Some of these things I've started doing naturally, like the array list, is just the default way I do collections now. But if they're not second nature to you, work the way you're comfortable and then start worrying about any optimizations, if that's even what you care about. And I'm not here to say, you should be caring about speed. It's just something that might come up. And test your code. So I mentioned on the previous slide, you might break a working script. If you've got good code coverage, if you do break your script, those should pick it up and you'll know right away, especially if you're making one change at a time, then you'll know what broke it. And I have a note, Glenn's doing a pester session at 3 and 4:05, so if you're interested in testing your code, go and see that. So, yeah, bang on time. So, you can get the slide deck, all the demo, all my VS Code stuff at that link. I sort of wanted to throw the floor open for questions or comments, but or hearing your favourite way of speeding things up. I will mention, I brought some chocolates from New Zealand, so if you come and find me at lunch, help yourself. But yes.
So I kind of how you mentioned like you guys make concessions for CPU or memory consumption by doing this kind of stuff. So what's a good way to do that?
Open Task Manager and keep an eye on it.
Where I'm at is now, all right, cool, this is really fast now, but the CPU is sitting at 90%.
Yeah. Well, and the thing is that might be fine if you're not using the system for anything else at the time. But yeah, the reality is just what I tend to do is have, you know, the resource monitor up and I just keep an eye on it. Thankfully, working in a place like New Zealand, I don't generally deal with massive data sets. So we're not dealing with thousands of AD users or tens of thousands of lines in a CSV file. So I personally don't run into it very often. Yeah. Yes?
One thing I found personally for increasing the performance, sorry, I'm not speaking out loud. Actually, I'll pass.
Okay, sure thing. Yeah.
I just recently went through a project of speeding up a health check we were running.
Yes.
Taking 14 minutes to run, and I went through each stage to look for ways to optimize it using parallel coding.
Yes.
And we went from 14 minutes to 90 seconds.
Nice.
Actually,
Okay, sure.
but one thing I found is it's requiring up a lot of jobs.
Yes.
The RS job, we're using the standard PowerShell job. Let's say you kick off 32 jobs simultaneously.
Yes.
There's initially a large increase. The jobs are a little bit longer running.
Yes.
If you just stagger them slightly, like average.
Yeah. Oh, I didn't mention that. I am doing the 100 iterations, but they're throttled to 25 at a time.
That was going to be my question, is what was the throttle? 'Cause
Yeah.
I found that if you set the throttle a little bit smaller, it completes faster.
Yes, yeah, so I set it to 25. For most of mine, that seemed to be the sweet spot. Cool. Anyone else? Awesome. Well, thank you all for coming.